The HiPAF range of high-performance aerated filters operates using the SAF submerged aerated filter process. These systems have been designed to treat the unscreened effluent from sites with population equivalents of 60 and above. The SAFs can be provided as part of an integrated system incorporating associated primary and humus settlement zones, such as the HiPAF, or as a discrete biological treatment system on larger sites used in conjunction with separate primary treatment units and humus tanks. This is an informational training video for maintaining the WPL's HiPAF system, although the information relating to the biozone and blowers is also applicable to standalone SAF units. The aim of this session is to ensure correct operation and maintenance of WPL's HiPAF plants. Included in this video will be on-site health and safety considerations, 3, 6, 9 and 12 monthly checks and disludging. A HiPAF is a packaged wastewater treatment plant incorporating a primary section, biozone section and humus tank. The primary section receives the flow of raw wastewater directly from the foul sewer in a controlled manner. The inlet and outlet to the tank are baffled to avoid disturbing the settlement of solids. This section also has a baffle across the tank to assist in holding back any floating scum that may occur. This is to prevent the carryover of solids to the biozone section. The design of this section reduces the upward flow velocity of the wastewater to less than 0.9 meters per hour at peak flows into the plant. This settlement reduces the biological oxygen demand of the clarified liquor flowing into the biozone by up to 10% and allows gross solids to settle out or float. The volume of liquor in this section also serves to equalise the strength of the incoming wastewater before it flows into the next section. An airlift forward feed provides an even flow over a 24-hour period. This reduces the level in the primary tank section by a maximum of 500 mm during periods of low flow. For example, at night to provide a balancing volume during the peak flow period the next morning. The biozone filter contains high voidage plastic media supported between two perforated plastic plates that allow the passage of air and effluent, but prevents any loss of media. The aerated filter section is split into a number of cells, each one having a dedicated air manifold and diffusers. WPL's innovative submerged aerated filter houses a hybrid version of two well-established biological treatment processes. It is a combination of a fixed film reactor system and a suspended growth floc dispersed growth system for bacteriological oxidation. This utilises the high transfer rates and operational control of the dispersed growth system, in which a wide range of wastewater digestion organisms develop in the form of a jelly-like substance known as biomass. The process of biological oxidation gives off carbon dioxide and humus sludge as a byproduct, with the supply of air introduced at the bottom of the filter by a series of bubble diffuser nozzles. A blower is used to aerate the filter and runs continuously. Sites are fitted with duty and standby blowers which operate on a duty standby weekly rotation and run simultaneously for 1 hour every 7 days so automatic scouring can be undertaken. The humus sludge produced as a result of bacteriological oxidation in the filter bed is transferred with the liquor into the humus tank section. The humus tank section is designed to allow humus solids to settle out in order to produce a clarified final effluent that can be passed to the environment, and the settled solids, known as humus sludge, are returned back to the primary section by two airlift systems which are controlled by timed solenoid valves. The humus tank is designed to remove the required amount of suspended solids and associated BOD in order to meet consent parameters. The sludge return airlift removes settled solids and some aerated liquor from the final settlement section and returns it to the first part of the primary section, thus enabling disludging from the primary section only. The recirculation of this treated liquor helps to keep the primary tank from turning septic and producing bad odours. The humus final settlement section is also fitted with a pair of scum skimmers controlled by timer solenoids. These are fitted to remove any floating scum which is returned back to the primary section. Supplied with the WPL HiPAF plant is the kiosk, which is a GRP body housing the blowers, controls and instrumentation required to run the plant. Kiosks have an optional telemetry connection which can be supplied. Please note that the timers are situated within the panels, therefore any alterations need to be undertaken by an appropriately trained member of staff. This film is intended as a guide and as such should be taken as a mandatory minimum for health and safety requirements on sites. As good working practice, we recommend a risk assessment be undertaken prior to commencement of works. All work should be carried out observing the requirements of the Health and Safety at Work Act, and all staff should have received an induction, the appropriate inoculations and the required level of health and safety training prior to commencement of work. Personal protective equipment should be worn at all times. As a minimum, this includes gloves, high visibility jacket or waistcoat, hard hat, steel capped boots and safety goggles or glasses. Every employee has a responsibility for not only their own safety but all others on site. This next section is a guide to maintenance needed to be carried out every 3, 6, 9 and 12 months as a minimum to maintain the HiPAF. Most sites will be visited more than every 3, 6, 9 and 12 months, some every 2 weeks. The following section is a general guide only and the site-specific maintenance schedule should be checked and followed. All of these checks should be carried out on a 3, 6, 9 and 12 month service schedule unless otherwise stated. Essential general checks that need to be undertaken are: checking the condition of all hatches, locks and hinges, clearing the rags from the pumps and airlifts, inspecting the cables, the floating sludge blanket should be no more than 200 mm thick and the top of the settled sludge should be at least 1 metre below surface. The test button on the main control panel will run for its preset time. To confirm forward feed is running, you are required to watch and listen to the exit point of the pipework within the first section of the buyer zone. Review and adjust airlift pump settings as required. Check the V-notch on the flow splitting chamber if one is supplied. This will be situated before the primary section of the HiPAF. Check the V-notch in the primary section and check that there is a drop in the level of the liquid between following sections and that the V-notches are clear of any debris. If the plant has been flooded, the V-notches may have become blocked. These should be cleared manually and the material should be returned to the first stage of the primary tank. Visually inspect and clear excess scum if required. Open the lids on the main unit and check that there is an even distribution of air around the filter. This will be indicated by an even distribution of bubbles on the surface of the biozone section. Check air distribution over the filter surface. Adjust, position and or clean air distribution nozzles as required. The media pack within the biozone is scoured on a duty standby rotation, which occurs a minimum of once a week. This is set on a timer, which can be adjusted to change the frequency of the automatic scouring process. A full manual media scour must be undertaken every 3 months or more frequently if the media is not being scoured sufficiently through this process. This is indicated by strong smells from the plant. Please note that scouring relies on both blowers operating simultaneously. It is therefore important that any blower faults are remedied immediately to minimise the time operating with one blower. To scour the media beds, pass all the air through each bed in turn for 10 to 15 minutes to remove any excess biomass from the media. Excess biomass is indicated if there is more than a 5 mm coverage of the media. Starting at the inlet of the biozone section, isolate all of the media beds via the main header using the main header valves. After 10 to 15 minutes, open the next media bed and turn off the first, and continue this process through the whole of the plant. Site-specific procedures should be employed to remove the scoured effluent from site, thus not allowing the scoured solids to pass to the final effluent sample point. Poor air distribution may mean blocked or broken air filters. To rectify this problem, turn off all but one of the air diffusers at the valves. Then proceed to check the one that is on for the position of bubbles. The increased pressure should clear any blockage in the diffuser. If not, the diffuser can be removed by isolating the individual ball valve and disconnecting the diffuser tube at the top of the valve, turning through 90 degrees and lifting up through the diffuser access slot. These diffuser units have a cap with a 5 mm hole in the end. In addition, there may be some cross holes on horizontal pipes. Ensure all holes are clear. Repeat as required for any other suspected blocked diffusers and then move the air diffusers by angling the tube as required to improve air distribution. Filter media may be partially blocked with biomass. This indicates that the plant is overloaded or poorly aerated. If this happens, check the design loading criteria and contact your process scientist or process engineer for advice. Filter media may be partially blocked with sludge. This may indicate carryover from the primary tank. To resolve this problem, check sludge levels and desludge if required. Also, check for excessive flow, possibly due to groundwater ingress into foul sewer. Clear excess scum if required. This can be removed manually by scooping it from the top of the biozones, or a tanker can be used to periodically hoover the scum from the biozone. Visually inspect and clear excess scum if required. Check weirs for obstructions. Check humus sludge return airlift times. After activating the sludge return test button, visually inspect to ensure that humus sludge is discharging into the primary stilling chamber. The timers may need to be adjusted based on the amount of clear liquor being discharged. Please refer to your operation and maintenance manual. Check scum skimmer airlift times. After activating the scum skimmer return test button, visually inspect to ensure that the scum skimmer is discharging into the primary stilling chamber. The timers may need to be adjusted based on the amount of clear liquor being discharged. Please refer to your operation and maintenance manual. Check panel trips by checking there are no warning lights or beacons showing and that all of the available run lights are illuminated. Check the extractor fan is operating and that the blower and control panel are dry and in good working order. Check that the ducts and luves into and out of the kiosk are clean and not blocked or restricted. Check panel trips by checking there are no warning lights or beacons showing and that all of the available run lights are illuminated. Ensure that the blowers have been checked on a weekly basis. Ensure both blowers are functioning and that there is no fault lamp showing. All blowers should be isolated from the electrical supply before maintenance is performed. Isolation of the blower's electrical supply should be undertaken by switching and locking off the main isolator on the front panel to off. Ambient temperature in the kiosk enclosure must not exceed 40 degrees. Ensure no dangerous mixtures, for example solvents, excessive humid air, water vapour, aggressive gases, traces of oils or grease can be potentially sucked into the blowers. Check that the blower air filters are clean and knock off any collected dust or replace the air filter if necessary. To replace the blower air filter, the blower must be isolated first. The filter is located under the black mushroom cap. To inspect or to change, undo the wing nut located on the top of the black cap. Lift the cap off of the retaining bar. Lift the filter off of the holding bracket and inspect or replace the filter. Filters should be inspected every 3 months and replaced at least every 12 months. Please refer to the manufacturer's manual for more information. If the blower is not running, please refer to the manufacturer's manual. Check manifold pressure. The hours run counter needs to be documented at each visit to ensure all blowers are getting even wear. Check for unusual noises from the blowers. The following are a selection of potential issues that may occur and their solutions. Power cuts. In the event of a power cut, if there is no fixed generator on site, make immediate arrangements for a mobile generator, or provide sufficient storage to prevent effluent discharge to the environment by removing the wastewater by tanker. It is important that if a generator is to be used on 3-phase supplies, check for the rotation of the blowers. Power supply faults. If a power supply fault occurs, switch off the blowers. Check fuses and any RCD breakers. On 3-phase supplies, check for correct rotation, switch blowers to on and the blowers should start. If not, switch off and call an electrician. A blower overload has tripped. If a blower overload has tripped, check for any obvious causes, reset overload and switch on. Blowers should start. If not, switch off and call an electrician. A blower runs intermittently. If the blower is running intermittently, the temperature may be too high. All blowers are supplied with high temperature trips. Check that the cooling fan is running and that the air ducts are clear. As per the WPL Operation and Maintenance Manual, desludging should be taken every 30 to 90 days. This is a site-specific parameter based on the sludge blanket level within the primary section or in the septic tanks, which should be checked on each operation and maintenance visit. The tank should never be allowed to become more than 50% full before being emptied. The frequency of sludge removal for each site should therefore be agreed with the process scientist. All sites have tanker connection points, bower couplings, to enable the sludge to be removed. An equal amount of sludge needs to be taken from each bower coupling, unless otherwise stated by the process scientist or site manager. In the primary section, the floating sludge blanket should be no more than 200 mm thick, and the top of the settled sludge should be at least 1 metre below surface. Whilst the tanker is on site, the biozone section should be checked for excess scum. If there is excess scum within this section of the HiPAF, the tanker can hoover the top off while on site. On sites with 2 septic tanks, tanker arrangements must be staggered to avoid removing the contents of both tanks on the same day. To ensure that all sludge is removed, each tank must be completely emptied.